Hi friends, this is Alakapan. This video is a continuation of Mule caching part 1. So in the last video we have just discussed how we can achieve the Mule caching with the help of Mule's default caching strategy which works with in-memory store. So we have seen the limitations of the default caching strategy where if you want to invalidate a key we could not able to invalidate it with the default caching strategy. And default caching strategy is more of something like you cannot achieve a reuse with the default caching strategy. If you want to reuse in the sense like you are storing some data, you want to achieve like that data storage needs to be there in two or three places of a flow where you want to do something with that cache data, you cannot achieve because the default caching strategy just holds a data in that cache, and that too in a particular flow. So um, in that case it is like you want to share something between the flows, or you want to share something between the application, you need an object store. So the object store will be created with a caching strategy which is of a customization of a default caching strategy. So you are extending the default caching strategy and you are making a reference caching strategy which you can refer it in the multiple places. So when you are creating a new caching strategy, you can have multiple option. You can make your store to behave it as an in-memory store or a managed store or a file store. So, and we have discussed all these three things in the last video. So in memory really holds the data in the JVM. So in memory it's suitable for if you are holding the data in one system, it's totally standalone. If you want to use that in-memory store across the servers in a cluster, you cannot do that because it relies the data storage on the one server. So if you want to take it across the cluster environment, Mule has the managed store which you can make use of it. And file store too. So file store, it persists the information in the file, but it still holds a reference of what sort of serialized content it has written in that file. It is having the reference in the JVM. So right now we are going to see a real-time example with how we can achieve the mule caching with the reference except the reference caching strategy, and that uses managed store. So let us look at what we are trying to cache it in this example. Let us describe the use case first. So recipepuppy.com. So this is a free public API. So I have invoked this free public API. So it give back me a set of response uh, like the list of recipes, and the list of recipe, each recipe what is the ingredients it has, along with the images where you can find the recipe. So it's like a totally a public REST API. So it is giving me a big JSON when I do just onions and garlic as a query parameter. We are not concerned about what is a query parameter we need to pass because it's having p is equal to 3, saying like the page number is third. So we are not concerned about the public API's query parameter. So we are just going to uh, make use of this API for our mule caching use case. So when I hit this one, it's an HTTP protocol API, so it's not an HTTPS. So it is giving me a big JSON. So my use case is like I don't want to hit it many time. So because uh, every API has set of rules like okay, uh, they might have a SLA rate limiting to ensure like nobody can hit this API for this particular time, these much time. So so they may have the rate limitation rules, because whenever you are going and hitting this API, so it is going and reaching their web server and it is going into the app server. So when they are exposing any API in the public, so they do have a limitation like, if you want to hit this API really lakh number of times or more than thousand number of times, just inform us so that we can make an arrangement for that. So if you are doing some example or something with this, so you need to ensure like you are not hitting them so often. So let us come back to the mule caching use case for this one. So I just created a simple project called recipe collection. So obviously it is having a main flow. So this main flow is listening at API slash receipts. So ideally I'm just allowing a get method, but I didn't specify any allowed methods. But still you can specify, because I'm not allowing a post or a put method here, because I do not have any logic for that. So and my core logic resides in this recipe puppy flow. So recipe puppy flow, it's a private flow. So the difference between a flow and a private flow is, flow and private flow are the two things that share one thing, like both are having a catch exception strategy holder. So in the sense like both can have error handling, flow and private flow, but subflow cannot have, because subflow operates in the calling threads hand. So but if you are making a private flow, make sure like private flow can create separate thread, and whenever you are calling a private flow, make it as synchronous. Like if you are having some background process request, you can have an asynchronous for this, but when you are having a private flow, make sure it to have synchronous to limit the threads, because every private flow will create threads actually. In the sense, every flow will have a selector runner, and nearly 8 threads will be created for every flow. So private flow also will create a equivalent of 8 threads. So make the settings in reference to what type of environment you are trying to deploy, whether it is a cloud hub or whether it is on-prem, because on-prem it came into the place where you need to control this threading and all, because you will deploy many applications, right? So make sure you are having the idea on how to use the private flows properly, otherwise it will create threads. It basically creates thread leaks if it is not configured properly. So let us discuss on the mule caching right now in this use case. So what I did is I created a cache key. So I just created a cache key. I just placed a static cache key because I'm just going and hitting this recipepuppy.com and pulling the data. So even that data is going to not going to differ across any number of hit. They are going to give the same data. So I'm just initializing the recipe as a cache key, and I'm wrapping my HTTP call. So the HTTP call, the HTTP requester is the one which is going and hitting recipepuppy.com with the get protocol, and what they're going to give is their big JSON. So in this big JSON, I don't want to have, for an example, what is the type of payload it has. So the recipepuppy.com has payload, and this payload has title, version, and the link to get the image out of it, and it is giving a list of results because we are passing some onion garling as query parameters, so it is giving some sort of results. So we are not concerned about their response, but we are trying to do some sort of transformation with their response. So in the results I'm having title, ref, ingredients and thumbnail. I don't want href and thumbnail, but I do really want title and ingredients, and result is totally an array. So I'm using this transform messages to do some sort of transformation because I told I'm just getting the title and the ingredients information alone. So just because they are giving results element with the list of the results of receipts, so I'm just iterating the payload dot results. Payload dot results will go to this place, so I'm just iterating it. So you can do the iteration in DataWeave with the help of map keyword. So I just placed a map. So that in turns it is something like when you can do an iteration. Obviously when you have an array you can do an iteration, otherwise you cannot write. So results is an array, so I am iterating it, and I just want to have the root name, so I just kept receipts. So title. So dollar indicates the payload, the running item. So if you put a for loop int I is equal to 0, so when you are looping it out, so you'll refer the current item with I. So dollar refers to the payload, so dollar dot title I'll get. And sometimes when they give the response with some new line character, say for an example, I just kept for this one, so for this one I'm getting broccoli oven omelette recipe, but I'm having some unparsed new line characters, so I do not want to cache this new line characters and all. So I just kept a replace function, replace method. So with it is replacing slash and whenever it is finding it, just replacing it with empty. So just to ensure I'm stripping out that characters and ingredients. So this is the array I'm forming it. So I'm having the receipts array out of it because I don't want the other information. And I really do want to store it in the cache because I don't want to hit this system multiple times. And if you want to store this one in the cache, I do really need a byte array to string or object to string or byte array to serializable to convert that stream data, because in the last session itself I told HTTP is also a consumable payload, and even a data weave, even when you set it to application JSON, that is also a consumable payload, because data weave is also going to provide you a weave stream as the output. So you do really want to convert the stream into a non-consumable, so you need some conversion which can grab the data which is coming in the stream, save it in the form of a java.lang.string. So that purpose is achieved with this. So the byte array to string I kept so that it can store it in the cache. So I'm just having the exception strategy, just ensure like if they are down, I should not cache it. If they are giving some 404, I should not cache it. So that's why I'm having a cache exception strategy. When it is breaking at here, it will not store it in the cache and it will go to the cache exception strategy where I am sending the HTTP status as 500 for now. It's 500 is internal server error, and I'm just setting the error payload, like setting some error code and description runtime error, just to facilitate like with this error code the front end can interface with some content management system to grab this error code, what is the value which is set over there, rather than just relying on the description. If they want to do something on the uh, content which is coming out of the description, they can do that, the front end systems which is interfacing this API. And if they really think like okay, that error code management is really done by the enterprise level systems, so if they need to be managed by some sort of business, so they can get this content from AEM or any caching, any content management system which can grab hold of giving the data. So this is the overall flow I have created, and I've just double clicked the cache here. So as I already mentioned, I have created a reference caching strategy rather than using the default caching strategy. So I just clicked on it. So I have created a caching strategy. Let us edit it. So what is that I have created is I have created a store. So this store is going to have the cached responses. So as I already said, like for any kind of request, the data is not going to vary. So the max entries I'm just limiting it to 10 because even though n number of records comes, so I'm not bothered about the number of entries which is going to store because it is will be always one. So I'm just keeping it to 10. And the entry detail is the one, it is like time to live. So first in first out. So the time to live, it's the one which keeps like how many number of milliseconds that it needs to retain that before checking like whether it needs to go and hit the real end time system or not. So entry detail ensures like the cache data will live for this much time. So it is like 3 days. And the expiration interval, it is like the frequency it should go and check actually. So the frequency where it should go and check whether the cache response is expunged or not. So that is also to do with this one. So this is also 3 days. So I haven't selected the persistent to true. So persistent means it is like you are storing the state of the data outside of this process. We don't want to do that actually because we want to have the persistent data only in case like it is not at all growing so much, and it's like more of a very much static because when you're storing something in the persistent store, it is like it is living in the state where it is outside of the process what you have created it. So I'm just leaving it persistent to false, and I'm having the key expression here. I'm just using the cache key as cache key, giving it OK. So let me run this one. Let us wait for a couple of minutes to get it deployed. So it's still in the starting state, so it is trying to get deployed. So it got deployed. So we'll invoke our API. So as you can see here, it get me the list of receipts. So when I hit for the second time, so how can I see like whether it is really fetching it from the cache or not when I'm running it in the running mode, not in the debug? So there is a Chrome ERC is there. We'll use the Chrome ARC. It's more like a postman. So let us invoke our API. So it's a get protocol, and I don't want to pass any content type for the get one. So it is just 29 millisecond. So it is really fetching it from the cache because it's not going and hitting the HTTP layer. So this tool is one of the very good tool. It's similar like Postman, where it is also having the interceptor here. So with that you can understand like when it is hitting the cache how much time it is taking, and when it is fetching it from the cache it's really fast. 29 millisecond is too fast because I'm doing some sort of transformation over there, and I am having an HTTP. So all those things will be happening at the first time, but for the second time it just going to fetch it. So it is just going to get the request from the listener and hitting the cache intercepting layer and get the response out of it. That's it. So I think we have covered the managed store with the reference caching strategy, and we have make use of some real-time API, and we are doing some sort of transformation here in this example. So let us do one thing in continuation to this. So let us deploy this thing to the Cloud Hub. How can I do that? Any point platform, deploy to cloud. So I'm just deploying it here. I'll select the worker size to less because it's really a test application, and that too like they are having some subscription limits, like based upon your subscription they will allow multiple workers. So it's a free one actually. You can use the Mule's Cloud Hub to test and develop applications. It really provides many options like including the runtime manager to control like how it is really working in the Cloud Hub. Then I'm deploying the application, how the runtime picks it up, and you can apply some policies also, permissions. You can play around with it. Like it's one of the real good features which Mule provides with any point platforms. It provides so much flexibility to analyze how the API is behaving in the cloud environment. So it's free of use, so you can use that. Of course, they are having a trial subscription for that. So I'm just deploying it into their cloud. So it's still deploying it. It is just still deploying it. I can go and click on the logs like to see what is really happening. So it is taking time to deploy it in the cloud. Let us wait for a couple of minutes. So it has deployed to an worker, and it is just starting the cloud hub worker. Let me refresh it. There are some good features over there. It's still just deploying it. Yeah, it got deployed. So it sets like your application is started. So I'll just go to the dashboard. So it is really providing the CPU memory utilization of all these things. So it got deployed into the recipe collection cloudup.io. So I just need to append my path actually, API slash receipts, right? So now let us see like for the first time how much time it is really taking, and for the second time how much it is taking it from the cache. So it got deployed into the cloud hub. So around say it 2079 milliseconds. So 2079 milliseconds, it's like it took 2 seconds actually, because cloud hub is reaching the recipe puppy.com. So when I hit for the second time, just 140, and for the third time 146, 146. So this makes like it is really fetching it from the cache. So cache cannot hide the performance, design, complexity of the API, because if you are doing something with your transformation that is like not in a better shape, cache cannot hide it, because the first time it really shows up like the max response time of your API call will indicate like yes, it has processed very much long. So you need to go and analyze why it has went so much time. But sometimes it really helps, because for a subsequent request you don't need to go and hit. At last average response time of the API also matters. So that's where caching really helps. So we'll close this window here. Yeah. So this is the example we have completed. Hope you have enjoyed this video. So I'll come up with one more example with mule caching in the next video. Thanks. Bye.